In morning lecture, we have started our some of the sensors as well as switches that we have seen in the morning lecture. Okay, out of that, we have started pneumatic switch. we पहिले जे आहे ते pneumatic switch आहे. Next one is the okay. What is the function of pneumatic switch? We have seen it is switch means nothing but simply we can say that our electrical switch. And that switch is used for on and off purpose. And in front of pneumatic means the switches which are controlled with air pressure. That switches are known as the pneumatic switches. Okay, we have seen these are the switches in morning session, as well as we have seen the four types of the pneumatic switches. Okay, which are those? First one is the diaphragm type, second one is the bellows type, third one is the Borden tube type, and last one we have seen piston type. Okay, these are the four types of switches we have seen in the pneumatic switches we have seen. After that, we have seen the pressure transducer. Okay, sensors and transducers are both are different. We have seen transducers are used for converting okay electrical mechanical mechanical outputs we can convert to electrical signals. Then we need these pressure transducers or the transducers. And here in pressure transducer, if you want to convert pressure into the pressure mechanical pressure into the electrical signals, then we need this pressure transducers. We have seen in morning session how it is working. Next, we have started with the proximity sensor. Again, sensors, these proximity sensors are used to detect or detection of object without touching any physical contact. Okay, to detect any object in the conveyor, we can say that, or the to find the presence of object in the conveyor, then we need these proximity sensors without touching to that object. Okay, त्या ऑब्जेक्टला न टच करता जर एखाद्या ऑब्जेक्टची पोझिशन जर फाइंड आउट करायचं असेल, पोझिशन किंवा प्रेझेंट आहे का तो ऑब्सेंट आहे त्या कन्व्हेअरवरती, हे जर फाइंड आउट करायचे असेल तर त्या केसमध्ये आपण काय करतो, तर वी आर युजिंग proximity sensors. As well as we have seen application of the proximity sensors in the morning lecture. After that, we have started this inductive type of proximity sensor. In inductive type of proximity sensors, okay, you can find there are different components inside that sensor, proximity sensor. Which are those? First one is the amplitude, or the we can say that pulses, or the ED current, induced ED current generator part. Okay. Second part, okay, here I have written. Second one is the oscillator, schematic trigger, and the last one is the amplifier. By combining all these four parts, okay, we can produce this inductive type of proximity sensor. Why it is called as inductive? Because its working principle, its work on inductive current, inductive current on inductive current. Okay, for that it is named as inductive type of proximity sensor. And proximity sensors are used for to detect the object. एखादा ऑब्जेक्ट प्रेझेंट आहे का नाही हे फाइंड आउट करण्यासाठी आपण जो काही सेन्सर यूज करतो तो म्हणजे काय आहे, तर आपला इंडक्टिव्ह टाइप. In inductive type of proximity sensors are only used for, okay, कशासाठी यूज करतो तर to detect metal object. Okay, एखादा मेटल ऑब्जेक्ट डिटेक्ट करण्यासाठीच हा आपण इंडक्टिव्ह टाइप ऑफ प्रॉक्सिमिटी सेन्सर यूज करू शकतो. Now how it's work? Okay, कसं work होणार आहे तर त्या ठिकाणी इथं okay, when we supply the input voltage to this coil, it will produce some induced ED current in front of the sensor. या सेन्सरच्या पुढच्या साईडला एक ईडी करंट इंड्युस्ड ईडी करंट प्रोड्यूस व्हायला सुरुवात होणार. ओके, when there is no object in front of this sensor. ओके, यावरती कुठलाही ऑब्जेक्ट समोर नाही, तर त्यावेळेस काय होणार आहे तर त्या ठिकाणी द induced ED current which is produced here, it is all induced current, it is collected by this amplitude drops. Okay, this collected all induced current is collected by here, and there is no voltage gap. Okay, if there is no voltage gap, we can say that there is no object in front of that. Okay, if the object is present in front of metal object, we can say that only for metal object we can use this inductive type of proximity sensor. If the object is present in front of this sensor. Okay, या सेन्सरच्या समोर साईडला एक ऑब्जेक्ट आहे, तर काय होईल तर त्या ठिकाणी इथं when we pass this induced ED current, okay, when we supply the current, it will start the producing induced ED current in front of the sensor. Okay, due to this object, metal object, it will cut this ED current field. Okay, it will cut this ED current. Due to this blockage of ED current, the voltage drop will across inside this. Okay, या ठिकाणी ED current कट झाल्यामुळे जो काही ED current field तयार झालेले ते कट झाल्यामुळे काय असणार आहे तर it will produce some voltage drop. Due to voltage drop, okay, it will indicate the object is placed in front of the sensor, and that depend upon voltage drop, it will produce the light outside. Okay, पाठीमागच्या साईडला light produce केली. Okay, in morning session we have seen the video related to the inductive type of proximity sensor. Okay, now that only I have written. Inductive proximity sensors are contactless sensor used to only detect metal object. Okay, here specifically I have written to only detect metal objects. For that only we need this inductive type of proximity sensor. Means it's based on the law of induction driving a coil with an oscillator once a metallic object approaches it. Okay, next, an alternating current is supplied to the coil, generating a electromagnetic detection field when a metal object comes closer into the magnetic field. Okay, next, ED current build up and result in coil induction changes. When coil induction change, the circuit that has been continuously monitoring will trigger the sensor output switch. Okay, some of the advantages and disadvantages of inductive type of proximity sensor. Which are the advantage? Contactless detection. Okay, this one is there is no contact between object and sensor. Environment adaptability, resistance to common conditions seen in industrial areas such as dust and dirt, capable and versatile in metal sensing, considerable, cheap when it comes to price. Okay, no moving parts, ensuring long service life, we can say that. And some of the disadvantages: lack in detection range. Okay, maximum range, we cannot use such kinds of the sensors. Next, can only detect metal objects. Again, this is large disadvantage, we can say that. Next, performance can be affected by external conditions, extreme temperature, cutting fluid, or chemical. Okay, some of these are the some disadvantages of the inductive type of proximity. Okay, in morning also we have discussed related some of parts related inductive type of proximity. Now we will move towards the capacitive type of proximity sensor. Okay, similar to the inductive, Similarly, in capacitive also there is one block inside that, like amplifier, schematic trigger, and okay, these are the part also present inside that capacitive type of proximity sensor. Here in capacitive, due to change in capacitance, okay, that field is generated. If now you can see here, there are again these proximity sensors are used to find whether object is present in front of or presence or absence. To find that, we need this type of the sensor without touching to the object. These are the capacitive type of proximity sensor. Here you can see here, there is one object. If there is no object, and if there is object in front of that capacitive sensor, capacitive sensors, and capacitive sensors mostly used for all objects, detecting all objects. कुठल्याही ऑब्जेक्ट डिटेक्ट करण्यासाठी कॅपॅसिटिव्ह सेन्सर्स यूज केले जातात. आता ह्या ठिकाणी बघा, ओके, यू कॅन सी ऑन युअर लेफ्ट साइड फिगर, okay, here there is no object. Okay, you know about that capacitive, okay, capacitive principle. If there is some change in capacitance means capacitance is depend upon the length, area, and the electric conductivity of the capacitance inside that electric plate. Okay, if the area will change or that dielectric material or the capacitance will change, it will observe, okay, some object in front of that. Okay, तर ह्या ठिकाणी जर ऑब्जेक्ट नसेल तर जेवढे काय रेज पास होणार तर ते सगळे काय होणार आहेत तर त्या ठिकाणी डिटेक्ट होणार. If the object will be there, then it will strike and it will cut that capacitance. Due to less capacitance, we can find there is some object in front of that. Okay, understood? फक्त एवढं लक्षात ठेवा, जर ऑब्जेक्ट असेल तर काय असणार आहे तर the capacitance will be same as supplied voltage, and if we change or if you place the object in front of that sensor, it will cut that, okay, capacitance, and due to cut that capacitance, it will generate less amount of voltage, and voltage drop will be there, and that voltage drop, we can say that will be any object in front of that plate. Understood? Here also that only capacitive proximity sensors are contactless sensors that detect both metallic and not metallic objects, including liquid, powder, granulars. It operates by detecting a change in capacitance. Okay, किती चेंज कॅपॅसिटन्स मध्ये झालेले त्यावरती हे डिटेक्ट करणार. Okay, capacitive proximity sensors produces a electrostatic field when an object, conductive or non-conductive, approaches the sensing area. The capacity of both plate increases, resulting in oscillators amplitude gain. The result amplitude gain triggers sensor output switch. Okay, and that only I have written. If there is a object in front of that sensor, it will cut due to that. Okay, if there is no object, then it will produce maximum amplitude, and that amplitude, it shows how it triggers the sensors, and it generates the output. Okay, if there is object in front of that, we can say that it will cut the inductance, and due to cut the inductance, it will create the small amount of amplitudes, and depend upon that amplitude, we can find the object in front of that sensor. Advantage is able to detect metallic and non-metallic. This one is the big advantage. We can say that well suited to be used in industrial environment. Again, we can say that contain potentiometer that allow user to adjust sensor sensitivity, such as the only wanted object will be sensed. No moving part, ensuring longer lifetime. Means there is no contact between the sensor and object. Okay, due to that, we can say that longer life of that sensors. But those are sensors which contact like limit switches. Limit switches, it is one type of sensor, okay, used to find the whether object is present or outside. Okay, to find that we can use the contact type limit switches, and non-contact type we can say that proximity sensor. Okay, next some of the disadvantages also there. Relative law range through incremental increase the inductive sensor. High price as compared to the inductive sensor. Okay, due to that inductive principle, it having the high cost. Now we will see actual working of that one, how it works.
నమస్కారం, నా పేరు అరుణ. మా ఆయన పేరు అనంతయ్య. మా సంవత్సరం తర్వాత ఒక పాప పుట్టింది.
You can see here.
In this video, I will be talking about capacitive proximity sensors. I will explain what a capacitive proximity sensor is and how they work. I will also talk about some of the different types of materials these sensors can detect, explain the main parts of these sensors, talk about some of the different types of capacitive proximity sensors, and I will give some examples of how these sensors are used with automation. If this is your first time notification, electronic device that can detect solid or liquid targets without physical contact. To detect
These are
these
the
targets, capacitive sensors emit
sensor
an electrical field from the sensing end of the sensor. Any target that can disrupt this electrical field can be detected by a capacitive sensor. Some examples of the solid materials a capacitive sensor can detect are all types of metal, all types of plastic, wood, paper, glass, and cloth. Capacitive sensors can also detect liquids like water, oil, and paint. Some capacitive sensors can be used to detect material inside a non-metallic container. The capacitive sensors used to do this have an adjustable sensing range. I will explain how to adjust these types of capacitive sensors with an example in just a bit. Capacitive sensors have four main parts: the sensor's body, the sensing face, the indicator light, and the cable or cable connection end. If the sensor has an adjustable sensing range, it will also have an adjustment screw to adjust the sensing range. Inside the sensor's body is where the circuitry is that makes the sensor work. The sensing face is the part of the sensor that is used to detect the targets. The indicator light is on the other end of the sensor from the sensing face. This light turns on when a target is within the sensor's sensing range and turns off when the target is out of sensing range. The sensing range of a capacitive sensor is the maximum distance a target can be detected from the sensor's sensing face. An example of being within the sensor's sensing range would be if the target is 6 millimeters away from the sensing range can be found couple screws into. The black wire is the hit. And turning the screw counterclockwise, other styles of capacitive sensor with, if I remove conveyor or robot so
you
they
can
know
see
when the
here
part
in
is there.
robot also how we
A
actually
capacitive sensor can be set up on a conveyor to trigger a counter so that it can count how many parts have been built. Capacitive sensors can also be used to check for high or low tank fluid levels and to trigger alarms for each. In review, by watching this video, you have learned about capacitive sensors. Main parts of, please let us know. This will help learn PLC programming in an easy to understand format and take your.
Okay, I hope you understood this one, capacitive sensor, as well as one more video with us that it will explain both that capacity as well as the inductive.
Ayaka shoulders her family's duty to cherish the aspirations of ordinary people. But she also has
दोस्तों की सॉल्यूशन में आपका स्वागत है। इस वीडियो है और इसका वर्क ये अब देखते हैं कि प्रॉक्सिमिटी सेंसर होता क्या है। प्रॉक्सिमिटी सेंसर किसी भी शेप का हो सकता है, किसी भी मटेरियल का हो सकता है, वो प्लास्टिक में हो सकता है, मेटालिक बॉडी हो सकता है,
Such kind of
वो किसी भी
sensors are there.
रेक्टेंगुलर शेप,
You can find in
कुछ मेटालिक
lathe
और
machines,
प्लास्टिक कंबाइंड
CNC
भी होते
milling
हैं।
machines.
सपोज हम एक ऑब्जेक्ट जो है काफी दूर रखते हैं सेंसर से, तो एक आउटपुट जनरेट हो जाता है। मान लो हम और पास रखते हैं तो कुछ सेंसरों में आउटपुट जनरेट हो जाता है। जब हम इसको बिल्कुल ही पास लेके आते हैं तो नियर बाय सभी के सभी जो है सेंसर है अपना आउटपुट दे देते हैं। तो एक्चुअली प्रॉक्सिमिटी है क्या? प्रॉक्सिमिटी का एक्चुअल मीनिंग है नियरनेस, मींस जो सेंसर्स जो है नजदीक से सेंस कर ले, मींस बिना टच किए, उनको हम प्रॉक्सिमिटी सेंसर कहते हैं। अब हम देखेंगे कि टाइप ऑफ प्रॉक्सिमिटी सेंसर कितने होते हैं। सबसे पहले हम लेंगे इंडक्टिव सेंसर। इंडक्टिव सेंसर किसी भी फॉर्म में हो सकता है। एज पर एप्लीकेशन ये डिजाइन किया जाता है, स्क्वायर बॉडी, राउंड बॉडी, मेटालिक बॉडी, प्लास्टिक बॉडी। सेकंड है कैपेसिटिव सेंसर। कैपेसिटिव सेंसर भी किसी भी फॉर्म में हमें मिल जाता है, सिलेंड्रिकल में ज्यादातर रहता है, प्लास्टिक बॉडी, मेटालिक बॉडी दोनों में अवेलेबल रहता है। थर्ड है फोटो इलेक्ट्रिक सेंसर। फोटो इलेक्ट्रिक सेंसर ज्यादातर रेक्टेंगुलर शेप में होते हैं या सिलेंड्रिकल शेप में होते हैं, ये भी डिपेंड करता है, कई तो फॉर्क टाइप भी होते हैं। फोर्थ है मैग्नेटिक सेंसर। मैग्नेटिक
Okay,
सेंसर जो
only
है
our
वो
syllabus
एक
inductive
एक्चुएटर
sensor,
रहता है और साथ
capacitive
में
sensor.
मैग्नेट रहता है जो डोर्स वगैरह के लिए यूज करते हैं। लास्ट है रीड स्विच। रीड स्विच, चलिए सबसे पहले देखते हैं इंडक्टिव सेंसर्स। इंडक्टिव सेंसर जो है ये डिटेक्शन ऑफ मेटालिक ऑब्जेक्ट्स के लिए रहता है। ये AC, DC, 2 वायर, 3 वायर, 4 वायर किसी भी फॉर्म में मिलेगा। ट्यूबुलर, रेक्टेंगुलर, रिंग टाइप, सिलेंड्रिकल टाइप, स्क्वायर टाइप, एज पर एप्लीकेशन ये डिजाइन होता है। अगर इसकी फंक्शनिंग की बात करें तो इंडक्टिव सेंसर का जो फंक्शन है हमने एक सिलेंड्रिकल सेंसर से उठाया है। इसके आगे जब भी हमें कोई ऑब्जेक्ट रखते हैं तो एक सेंसिंग फेस रहता है। जो सेंसिंग फेस जब सेंस करता है तो ऑसिलेटर उसको सिग्नल देता है। उसके बाद एक ट्रिगर लेवल सिग्नल जनरेट होता है, जो जनरेट होने से एम्पलीफाई उसको एम्पलीफाई करके एक आउटपुट देता है जिसको हम किसी भी फॉर्म में यूज कर सकते हैं। दोस्तों अब हम बात करेंगे कैपेसिटिव सेंसर्स की। कैपेसिटिव सेंसर जो है ये मेटालिक, नॉन मेटालिक ऑब्जेक्ट्स दोनों को सेंस करते हैं। मेटालिक में हम लोग देखेंगे तो ये स्टील, कॉपर, ब्रास, एल्यूमिनियम, सिल्वर, गोल्ड, किसी को भी प्लेटिनम, किसी को भी सेंस करेगा जो मेटल के हों। लिक्विड में ये वाटर, ऑयल किसी को भी सेंस करेगा। प्लास्टिक में कोई भी प्लास्टिक हो, चेयर, बॉटल्स किसी को भी यूज सेंस कर सकता है। वुडन में ये सारे वुड्स को सेंस करता है। डिस्टेंस अलग अलग उसमें रहेगा। ये AC, DC, NO, NC सिलेक्टेबल रहता है। इसमें एडजस्टेबल इसका ऑपरेटिंग रेंज रहता है। 3 और 4 वायर दोनों में अवेलेबल रहता है। अभी बात करते हैं इसके ऑपरेटिंग प्रिंसिपल की। ये एक लाइक सेम कैपेसिटर की तरह होता है। इसमें एक डाइलेक्ट्रिक मटेरियल होता है, ऊपर एरिया रहेगा। जो कैपेसिटेंस है वो एरिया से एरिया इनटू जो है डाइलेक्ट्रिक जो स्ट्रेंथ रहेगी वो डिवाइडेड बाय इसका डिस्टेंस। तो जैसे ही हम इसके पास में कोई भी ऑब्जेक्ट लाएंगे तो ये एक आउटपुट जनरेट करेगा क्योंकि इसके डाइलेक्ट्रिक स्ट्रेंथ में चेंज। अब हम बात करेंगे फोटो इलेक्ट्रिक सेंसर्स की। फोटो इलेक्ट्रिक
Okay,
सेंसर
this is about the inductive and proximate sensor. You can see other videos also. Yeah, we don't go to the other, otherwise it will take too much time. Next one is the range sensors. Now might be seen in robots there are different range sensors are used. Range sensors are used for what is the function of range sensor? It is used to measure the distance between the object and a reference point. Okay, to measure the distance we need this range sensor. There are different types of range sensor. We will see now. Only you can remember that range sensors are generally used to measure the distance between the reference point on the robot and the object present in its workspace. Okay, डिस्टन्स मेजर करण्यासाठी आपल्याला काय लागणार आहेत तर रेंज सेन्सर गरजेचे आहे. द सेन्सर्स आर युजेस फोटो इलेक्ट्रिक डिव्हाइसेस टू डिटरमाइन द distance. Okay, Now, first one is the range sensor. We can say that ultrasonic sensor. Okay, ultrasonic sensor they used to detect the distance. एखाद्या ऑब्जेक्टचं डिस्टन्स फाइंड आउट करण्यासाठी आपल्याला किंवा ऍज अ रेंज सेन्सर म्हणून आपण त्या ठिकाणी यूज करू शकतो. अल्ट्रासॉनिक, इट्स नेम इटसेल्फ, यू हॅव हर्ड दिस. अल्ट्रासॉनिक means sensors which are detecting the presence of object through emitting high frequency ultrasonic range. It does so through the conversion of electrical energy. Means you can see here, it will pass. There are two one is the transmitter for ultrasonic waves and a receiver for ultrasonic waves. Okay, from one side it will transmit ultrasonic waves, and another end it will receive the ultrasonic waves. Depend upon the range, it will detect the number of time, or we can say that time required to detect the or receive the ultrasonic wave. Depend upon that, we can see the distance from the object and the, or simply we can say object. Object आणि ऑब्जेक्ट मध्ये किती डिस्टन्स आहे हे आपण त्या ठिकाणी फाइंड आउट करू शकतो. नेक्स्ट, सिमिलर टू कॅपॅसिटिव्ह सेन्सर, इट कॅन डिटेक्ट ऑब्जेक्ट इन सॉलिड, लिक्विड, ग्रॅन्युलर ऑफ द as well as granular form. Okay, the sonic transducer emits sonic waves. Sonic waves bounce off the object. The wave that bounced off in the return to the sensor, time that it took to emit and receive the sound waves is used to determine the distance of the proximity. म्हणजे किती लांब ऑब्जेक्ट आहे किंवा किती डिस्टन्स वरती हे फाइंड आउट करण्यासाठी काय केले जाणार आहे, तर त्या ठिकाणी साऊंड वेव्स ट्रान्समिट केली जातील अँड दॅट डिपेंड अपॉन द सेंडिंग अँड रिसिविंग दॅट साऊंड वेव्स. Okay, it will find the time required for sending and receiving. Depend upon that only we can find the distance of object. Okay, some of the advantages: no affected by object color and transparency. Okay, there is no any effect of object and color. There is not affected any external environment condition, reliability, solution. Work well in place with extreme condition, able to be used in dark environment also. Low current consumption, and some of the disadvantages are like limited detection range through capable of higher range as compared to the inductive and capacitive sensors. Does not work in a vacuum since ultrasonic sensors operate via sound waves only. Okay, if there is a vacuum, we cannot use such kinds of the ultrasonic sensors. Not able to measure the distance of soft object or the one with extreme texture. Okay, those objects which will absorb the sounds, that object cannot be found with this help of ultrasonic sensors. Now you can see here there is one symmetric trigger, or the we can say that ultrasonic wave transmitter and a receiver. Okay, in one video actually how it will transmit, it is shown. Just we will watch that video, means you will understood clearly how actually transmitting and receiving. See that this video, ultrasonic sensor. Here they have explained
the ultrasonic sensors with IO link from IFM, the solution for problematic surfaces. Reliable sensors are indispensable for conveyor technology. IFM offers precise ultrasonic sensors among other devices for cases like this. They can be used on conveyor belts for the detection of various objects. Ultrasonic sensors transmit sound, which is reflected by objects that move past them. They are particularly well suited for demanding objects like flat, shiny, and transparent objects, independent of form, color, and structure. But our sensors are capable of more. Using a reflector, objects are recorded independent of orientation. Even sound-absorbing objects like sponges are recognized without difficulties. Even precise diametric detection is possible with ultrasonic sensors from IFM. Another area of application for ultrasonic sensors is for continuous level detection in tanks. For differently sized tanks, we offer sensors with various ranges. For use in tanks, it is important that the sound does not collide with the inner wall, influencing the measurement negatively. A sound tube can solve this problem. With the help of this accessory, a smaller sound beam is produced. Even for tanks with even larger volume capacity, we offer suitable sensors with ranges of up to 8 meters. Via IO-Link, the width of the sound beam can easily be reduced or increased. Ultrasonic sensors with IO-Link from IFM, equipped for any range. Convinced? Learn more about ultrasonic sensors on our website.
I hope you understood this one. Next one is the how actually detecting. Only there are two elements. One is the transmitter and one is the receiver. From this one, sound waves are passed and here it is received. Depend upon the distance traveled, okay, a time required to send and receive. Depend upon that distance will be calculated. Next, infrared sensor, or it is popularly known as a IR sensor. Okay, IR in the short form of infrared, we can say that detect the presence of an object by emitting a beam of infrared light. Means here also it is similar to ultrasonic. Here it will in ultrasonic the sound waves are passed and here infrared lights are passed. Okay, that infrared, okay, there are also IR emitter and IR receiver. Two are there. Okay, from IR emitter, it will emit the light, it will fall on the object, and by reflection of that object, it will detect the IR receiver. Depend upon this traveling time, okay, we can find the object distance. Okay, how far object from the sensor पासून किती लांब आहे आपण त्या ठिकाणी बघू शकतो. Infrared light is emitted from the IR LED emitter. The beam of light hits the object and gets reflected back in an angle. The reflected light will reach the light detector. The sensor in the light detector determines the position, distance of reflection object. Okay, simple construction and working is there. Next, some of the advantages, disadvantages also infrared sensors are. Which are the advantages and disadvantages? Advantages are applicable for daytime and nighttime usage. Connects secure communication through a line of sight. Able to measure the distance to soft object unlike ultrasound proximity sensor. Accuracy of the infrared sensor not affected by the corrosion or oxidation. These are the some of the advantages of this infrared. And the disadvantages, which are the disadvantages of infrared? Affected by environmental condition and hard object, implying mobility for usage to walls or doors. Required line of sight between transmitter and the receiver for communication, and performs dips over long distance. Okay, these are the some of the advantages and disadvantages of IR sensor. Okay, and industrial, how it is these IR sensors are used. Now we will see, and we will move towards the next one is the microwave sensor. Just we will watch this one, how actually it is done, because we should know how actually this works.
Compliments and compliments. Everyone just loved my presentation, and I only spent 30 minutes on research. Other
This is an infrared sensor. It is designed to emit and detect infrared light. It has two LEDs. One emits the infrared light and the other one detects the infrared light. So let's connect it with Arduino and try to understand how it works. So talking about the pinout of infrared sensor, the VCC pin is connected to 5 volts of Arduino and ground pin to the ground pin of Arduino. And as shown, the output is connected to analog input pin 0 of Arduino. Let's see the emission of infrared sensor, and it's working. So without any obstacle, no infrared light reflects back. When an obstacle is placed, the infrared light reflects back to the LED that detects the infrared light and gives a signal to output pin, which is connected to Arduino. And we can read it through Arduino serial monitor. Let's see a graph with and without any obstacle. I hope you understand about how infrared sensor works.
Might be understood this one how actually it is working of infrared. One is the light emitter and one is the light receiver or the infrared receiver. If there is an object, it will receive. Otherwise, if there is no object, it will emit only the light. Okay. Next one is the microwave sensor. Okay. Here you can see here device having microwave sensor generate microwave signals which cover certain area across the space. When a person walk into the microwave zone, this body causes wave to reflect and this is detected by a sensor to take appropriate action. Means suppose this one is the microwave sensor. Here again there is one emitter and one receiver. Okay, it will emit some microwaves. If there is no object, it will continuously emit. There is no received by this receiver. If there is object in front of this one, it will receive the microwaves and it will generate some output. काय करणार आहे तर ते output generate करणार. Okay. Some of the advantages of this microwave sensors are, which are those? Sensitive to slight movement, wide coverage range of about 120 meter. Means these are used for wide range. Okay, maximum range for this definitely which microwave sensors are helpful. Can detect any motion, even body and walls or behind the doors. They have definite of high interference immunity, high precision, high reliability. They can be used in harsh environment where heat cycle are irregular. Okay, and some of the disadvantages: prone to false detection due to high sensitivity. Sometimes they detect non-human presence such as animals, fast-moving objects in the air. Microwave frequency do not penetrate metal objects and hence microwave sensors cannot reach beyond any metal abstraction. Okay, next, microwave radiation is hazardous for health, hence low level radiations are used. Okay, we will watch this how actual microwaves are transmitted and it is received with the help of one video. To detect any object detect करण्यासाठी कसे यूज केले जातात आपण बघूया. You can see now microscope. It is similar to your IR sensor, infrared sensor. It is
In this video, we're going to be looking into this microwave motion sensor released by DF Robot. What's new about this sensor is its mechanism is based on the Doppler effect. It has a pair of antenna for both emitting and receiving microwave. The frequency of emitting microwave is around 10.5 gigahertz. Same as other distance sensors, the microwave sensor senses objects by collecting the echo of the EM wave sent out by itself. Traditional sensors sense the distance by measuring the timing interval between emitting and receiving a wave signal. When other conditions stay unchanged, the longer this interval is, the further the distance. However, for this particular microwave sensor, instead of sensing the time interval, it measures the frequency shift of the echo. The frequency shift is only related to the speed of the object. When an object is moving away, the wavelength of the echo will be stretched, which leads to a red shift. Likewise, an approaching motion leads to a blue shift. The echo picked up by the antenna will be sorted out and amplified for spectral analysis. When a frequency shift is detected, the sensor generates a high-level digital signal. Meanwhile, the LED indicator lights up. Despite of the fact that this microwave sensor is not able to measure distance directly, compared to traditional distance sensors, it has a larger detecting range with better sensitivity. It's even able to detect objects through a wall and can be operating under a wider range of temperature. Using this sensor is rather simple. Set a sensing range from 2 to 16 meters by adjusting the onboard potentiometer, connecting to the circuit, and install it at the place you want. You can visit our wiki page for the sample code and more details about the microwave sensor. The sensor belongs to the DF. It comes in the microwave sensor site. This is
I hope you understood this microwave sensors. It's similar, it is your ultrasonic and IR sensors. Okay, it will transmit only microwave and depend upon the object, it will receive that microwave. Next one is the laser sensor. Okay, so next laser sensor and the vision sensor. 2 R sensors are remaining. After that, we will start the inertial measurement and last one is the global position. Only these many sensors are remaining. After that, our sensors part will over, and we will start the new part of this one is the actuators. Means one more lecture we require to sensors, and after that we will start the actuator part. Okay, now we will move towards the laser sensor. Laser sensor, again, this definition of laser sensor is it is an electrical device used to sense minute object and precision position. This sensor uses a laser to produce a light within a straight line. Its visibility ray mark of the laser makes arrangement very simple. Laser light includes light waves with similar wavelengths. Because of the reason the beam travel is parallel direction. Means in that it will transmit the laser light and depend upon the traveling distance it will find the object position. Okay, advantages, the range of measurement and the distance is large. Okay, larger range distance we can measure with this laser sensor. Resolve capacity less than 1 micron at a diffraction price. Okay, and some of the disadvantages are the accuracy of the sensor can be detected by can be affected by dust or other materials. Means the accuracy of laser it is less due to the some dust or the dust particle and other materials in the environment. And second one is damages eyesight. Means if larger the distance, these lasers are very dangerous for human purpose. It may be also it is affected on our eyes also, and it will reduce our eyesight. हे आपण त्या ठिकाणी आपली जे काय डोळ्यासाठी ते भरपूर अपेक्षित आहे. Now we will see one video related to that one. You will understand how it is work.
Time to scout.
You can see now how actually such kinds of laser sensors are there. You can see. You can see here, if object is in front of that laser, it will detect. It will blink that light. I hope understood this one. Laser sensor also how it is work. Okay. Next one is the vision sensors. Okay. Vision sensors, we can say that it is used for detecting the object. Okay, you can see here similar to our eye. Okay, ज्या पद्धतीने आयचं फंक्शन आहे आपल्या डोळ्याचं फंक्शन आहे त्या पद्धतीने काय असणार आहे तर त्या ठिकाणी तर विजन सेन्सर असणार आहे. Okay, it will suppose this one is the image, then what is the process? Image plan, imaging system, scan object. These are the some parts of image generation. कशी इमेज जनरेट होते त्याचं तुम्ही त्या ठिकाणी बघू शकता. Okay, we will discuss this image processing in the next lecture about how that image processing is carried out. Okay, as well as we will move towards the inertia and global positioning. Okay, and after that we'll start our actuator part. Okay, if you have any problem up to laser sensor, then you can ask me. कोणाला काय प्रॉब्लेम असेल तर तुम्ही विचारू शकता. Otherwise we'll end today's session. Anybody having any problem in this up to laser sensor? If there is no problem, then you can write your roll numbers in chat box and you can leave the meeting. No problem.